Recording in progress.
There are total of 6 trig functions. We're going to take a look at the last 3 trig functions for inverse trig functions. So with today's lesson, we're going to look at the inverse of secant, cosecant, and cotangent functions. We're not going to worry about their graphs so much, but we're going to learn how to find the value for them. So if you look at the definition of the inverse secant, cosecant, and cotangent functions, so secant is the reciprocal of cosine function. So when you have y equals inverse secant of x, this is how you would express the function. And really, the domain and range for these 3 different functions, they don't matter as much as the other 3. So I'm just going to go ahead and show you the next objective about finding the numerical values for these inverse trig functions. So if you do see a question like, find the exact value of inverse secant of 1, so basically this question is asking you, what is the angle whose secant value is equal to a 1? Personally, me, I would like to go back and change them to the cosine function because secant is the reciprocal of cosine. So for what function reciprocal of 1 is still 1, so I would ask myself, for what angle cosine value will be 1? And I will just focus on the domain of the cosine function, which is the exact same interval as the domain for the inverse secant function, so from 0 to pi. And then if you remember, cosine of 0 is 1. So for this question, the correct answer will be equal to 0. So this part is the answer for the previous question. Inverse of secant 1 is equal to 0. So if you do understand the first section very well about inverse sine and inverse cosine, you can always transfer that knowledge to this section. Next question, I want to find the exact value of cosecant, inverse cosecant of 2. Cosecant is the reciprocal of sine. So I would first find the reciprocal of 2, which will be 1 over 2. So the question to myself is, what is the angle whose sine value is equal to 1/2? And remember, for the sine, the domain is negative pi over 2 to the positive pi over 2. This is the domain for the inverse sine function. So I'm going to have to give them an angle from negative pi over 2 to pi over 2, where the sine value is equal to 1/2. And I know that the only angle who has a sine value 1/2 is 30 degree, which is pi over 6. Therefore, inverse cosecant of 2 is equal to a pi over 6. So for this slide, you should really obtain the answers for this type of questions using calculators, since only a calculator knows the exact values for these inverse trig functions. So you're going to use a calculator. You're just going to type the question and then find the answer for these 4 questions. And then you just have to make sure that your calculator is in radian mode for these questions, because that's what they're asking for this one. And that really takes a lot of space, putting these questions to calculator and explaining which answer you're going to choose. So the last objective here I want to look at is find the exact value of the composite functions involving the inverse trig functions. So when you have nested functions like this, so when I look at my current problem, I have an inner function here. I need to find the inverse tangent of 4 over 3. And then I want to take the sine value of this. I am going to share how I would approach this problem. For this question, we're going to copy this portion. And then we're going to paste it on the board. So the nested function here is, I do need to find first the angle. So the angle with tangent theta is equal to 4/3. So I want to just label this part as x. So the x is equal to inverse tangent of 4/3. And then since I labeled the whole thing as x, my question is, what is sine of x right now? That's what the question is asking me. Now, I'm going to go ahead and draw a right triangle here. And then I'm going to put the angle x here. So I am looking for the angle with tangent theta is equal to 4/3. If you remember, tangent of any angle is always opposite side over the adjacent side. So therefore, the opposite side will be here 4, and adjacent side will be here 3. So I need to find the hypotenuse because sine of any angle is equal to opposite side of hypotenuse. So I have the opposite side of x here, but I'm missing the hypotenuse. So 3, 4, in order to find this missing side, c squared is equal to 3 squared plus 4 squared using Pythagorean theorem. And you will definitely find that this missing side must be a 5. So now when I am looking for sine of x, which is opposite over hypotenuse, and we know that this missing side is equal to 5, so the answer they're looking for in this problem is 4/5 for this question. So on the slides, this question will take us to the answer. And the answer should be here, 4/5. This is what the answer is. They do the same way I did, but they just put more explanations here if you want to read in detail. So that's how you find the 4/5 here for this question. We have another very similar one. So I'm going to cut this question here also. And then I'm just going to cut this big. And then this time it is a negative value that I have to be careful. So I'm going to come here. So we are looking for the exact value of this one. I'm just going to move this away. So I'm looking for the exact value of cosine of inverse sine of negative 4/5. I'm just going to use the same approach. I'm going to go ahead and label this whole thing as x. So according to my logic, x is equal to inverse sine of negative 4/5. So basically, I'm asking myself, who is the angle whose sine value is equal to a negative 4/5? And I just have to remember that sine is only negative in the second quadrant. So if you remember the domain for inverse sine function, right, they can only exist from negative pi/2 to positive pi/2. That's the domain for inverse sine function. And now, because sine of any angle is always opposite over hypotenuse using the right triangle technique, so I'm going to place this. So let me put the angle x here. Its opposite side is 4, and then hypotenuse is 5. We already saw this spatial right triangle, which is 3, 4, 5. So the adjacent side needs to be 3. So this question is asking for cosine of x. Now, if this was a positive value, it was very obvious that cosine is adjacent over hypotenuse, right? So cosine of x, if it was an acute angle, the answer will be 3/5. However, this one here, because sine value is negative, the answer must be 90 plus x. So whatever the acute angle, it's going to be 90 more than this. So the cosine is going to be a second quadrant. So I'm trying to find the cosine value of the second quadrant angle. Therefore, we're just going to make it negative 3/5 here because of the domain of the arcsine. So I am taking you guys back to the slide. And then here, they did get a positive 3/5 here. This is an odd function, but this is an odd function. Let me see. They got the value as 3. Oh yeah, sorry, my bad. So because of the domain of the arcsine, instead of finding the angle in the first quadrant, we're going to find the angle in the fourth quadrant. Fourth quadrant sine and cosine value, they're still positive, therefore the answer is going to stay as positive 3/5. Now, I think we can do this question. If it doesn't require a calculator, and it doesn't. So I'm just going to go ahead and cut this question now, which is a combination of inverse cosine and tangent. I will go to the board and then put the question. Okay, we will apply the same strategy. I'm going to go ahead and call this as x. So x is equal to inverse cosine of -1/3, which means this question is asking me to find tangent of x. That's what they're asking me. And then if I rewrite this, this means then cosine of x is equal to -1/3. Because if you remember the functions and their inverses, they will exchange x and y values. So I'm going to go ahead and make my right triangle. And then x, adjacent side is 1, hypotenuse is 3. So using the Pythagorean theorem, I need to calculate the missing side. So if I just go ahead and label this as a, 1 squared plus a squared is equal to 3 squared. So a squared is equal to 8 because that's 9. 9 minus 1 is 8. So a will be square root of 8, which is 2 radical 2. So the missing side is 2 radical 2. Now, however, the cosine value is negative. So remember, for cosine, for inverse cosine actually, we can only use values from 0 to pi. So this must be an angle who lives in the second quadrant. So I do have the missing side, but this angle x, is in second quadrant. So therefore, in second quadrant, tangent value will be a negative. And then tangent is opposite over adjacent. We just got the opposite side as 2 radical 2, and adjacent side is 1. Therefore, the answer to this question will be 2 radical 2, but it will be negative because of the quadrant calculations. And that's all about this section 6.2.